This video is all about 3D printing custom fairy-light covers, and every single cap you can see here, from the faceted sort of conical caps to this pygmy lamp or this tubular lamp, these are all printed using a standard 3D printing script that I've actually put down in the description down below. So if you want to make these caps, if you want to experiment and play about with doing stuff like this, if you've got a 3D printer, if you're getting one, you can actually copy and paste the text down below in the description of this video into OpenSCAD and you'll be able to make lights just like this. Okay, let's take a look at the script and what the variables are. And just so you know, I'm about to bring the light back, so things are about to get very bright. Watch your eyes. The light is back. Let's take a look at the script. So what you're going to be doing here is that if you want to try this out, you're going to have to download a piece of software called OpenSCAD. It's freely available. I shall put a link to it in the description down below the main website. When you've downloaded that, you will find you've got a window at the left for text when you open the window, and you've got a window at the right for the graphics when you open the window. And OpenSCAD is one of these things that just play about with. That's the best way to learn to use it. When you want to actually put this script in, you want to clear this area here for a new document. And you want to basically copy and paste just the text that is down below in the description that I've highlighted down in the description. And when you copy that and you paste it into here and you press the build button, and that's the little box with the double arrow on it, the high-speed build, it should create something like this that you can then adjust because you have variables. The variables you've got can adjust the shape of the lamp. You've basically got a top sphere, a bottom sphere, and then you can specify the height of the lamp, and you can specify things like the number of facets around the outside. In the case of this one, I've got 12 facets around this, which gives it a nice shape, whereas this one has 100 facets, which gives it a nice smooth finish, like a traditional vintage lamp. So the variables you can change are top, which is the top sphere here, bottom, which is the bottom sphere here, and it will then join those, but you can specify height. It will base the height on from the bottom of this sphere that you've specified to the top of that one, and it will join them together. Then you can specify facets, and that's the number of facets around this. It's worth mentioning, because this uses the hull command in OpenSCAD, because it turned out to be a lot easier than trying to do it mathematically myself. The hull command lets you place a couple of objects, and then if you put them in the hull command, it will basically join them together, and that's what I've done here. So that joins the two spheres with that straight line. But the more facets you add into it, say for instance, if you start off with the low resolution 12 facets, it will build that very quickly. But this is more important when you're prototyping. But once you actually choose a higher number of facets, like 100, it will take consummately longer to build. It takes a lot longer to build it. So it's worth mentioning that. There are a few quirks about OpenSCAD. When you press build, it's not always obvious that it's still busy. It looks as though it may have crashed sometimes, but it is building in the background, going with a cup of tea. Then you hear it go bling, and the object will appear built. It's also worth mentioning that when you finally save that object after you built it, it takes a while for it to save, but it's doing it in the background. So it sort of goes away and does its saving thing, then comes back. This is free software. Don't have expectations of professional polish. It's all geared up to pure maths and understanding how the software works, but you don't have to know too much. The other adjustments you have here are base len, which is the length that sticks out here from the bottom of the base. The inside diameter is the inside diameter of the base. So in this case, what I've got here is I've measured this at about 9 millimeters. I've made the inside diameter here 9 millimeter, and I've chosen a fairly long length. On the other hand, I chose, for these ones, I chose a much shorter length, and I chose a thinner inner diameter because it's just going over a simple LED. These are great. As it comes, the script will be optimized for these little standard heat shrink LED strings, but you can tweak and adjust to match whatever you want. The bigger ones I made here are designed to go over standard tungsten fairlights, but ones I've adapted to LED with a separate power supply, and it runs all the LEDs in series. I've featured this in other videos. I wouldn't recommend putting tungsten lamps into these because there's a risk that the heat could rise too high in them, and it could pose a melting and fire risk. That's me covered my ass by saying that. I chose them for LED. LED will be a good look. The other variable you've got here is LED. The LED is actually the size of the hole inside because this is designed for LEDs. Let me show you what you're going to end up with here. This is an X-ray through what you're going to end up with. This is the base that the LED is going to push into. This is the shell. It's deliberately hollow. You don't need to do anything fancy like use VAS mode or anything like that in a 3D printer. All you have to do is print it as a solid object because everything is already designed. It's got this 1mm shell, which is just perfect for rigidity and light transmission. And the bit that the base lens, the bit that it sticks out, there's also, out of sight, there's another bit inside, all angled and shaped to actually 3D print correctly. And it just lifts the LED into position where it's actually going to be roughly central to the bottom globe for maximum illumination. The hole that I was mentioning, the LED hole, is this hole here. And as you scale this, these sides will just taper in automatically and adjust to accommodate that. And the reason for that hole is to leave a lip basically here that the LED won't just shove. You know, if it was too big a hole, it would just shove right inside the lamp like that and get lost inside, which could be an interesting effect in its own right, to be honest, if you shoved several LEDs in. But that's what you're getting here. So that's the inside of the base, length of the base, and that's the LED hole at the end. In the case of these ones, I made the LED hole quite big. That's actually one of the covers that I've used for the traditional tungsten bases, just so it didn't actually fill the LED, so it could just go in easily. Because there's plenty of lip there just to stop the whole holder going in. Things worthy of note. If you're not used to writing script, be very careful to only change the numbers. There'll be an equal before the number. There'll be a semicolon after the number. It's important to keep those in place. If you make a mistake, it will basically stop the script from working. It will flag little warnings, particularly if you accidentally delete that little semicolon. It also says don't touch variables below this line. Although they look adjustable, don't adjust them because it will stop it working. So once you've actually got what you like, you can see an instant or a very quick rendering just by pressing the little double arrow here. And there's a little button with the double arrow here. Once you've got what you like, you can then build the STL file for your slicing and printing stuff. And to do that, there's another little box that has a hourglass in it, the little sand timer, and there's another one down here, the same button. If you click that, it will then start building it properly in putting all the details together in much more detail, so to speak. It's a much bigger file. It's important to note that when it does that, it does tend to sort of go away and think about it for a while. Just be patient, go and have a cup of tea. It will come back and you'll have your solid object. When you want to save that as an STL file, click STL up here and it will save that file. Also note it goes away and does it for a wee while, but then comes back. You may notice the cursor disappears for a while and then appears again once it's done. It's little quirks. It's fine. It's what it does. And once you've got that file saved, then you can load it into Cura or whatever and then print it in the printer. Things worthy of note. It prints from the base up the way. So if you've got a printer, if you've had problems with adhesion, it's worth using a little raft in the bottom to support this. Once it's finished printing, I print directly onto a heated plate. The FL Sun is very good that way with the heated plate. It gets good adhesion. But it tends to squish the first layer. I suppose there's a way around that, but I find it's useful just to stick the little cutters you'd use for your filming in and just give it a quick reamer like that, just to clean the rag off that side, and then you'll find it fits over the LED perfectly. The diffused colours look very good. I originally designed this around the clear material, and when you've got the clear, as you'll see here, you get that sort of lensing effect. It's quite interesting in its own right. It looks like the filament inside a clear lamp. But when you use a clear LED in the diffused, you get the sort of slight ripple, the sort of an uneven light distribution. But if you use a diffused LED in the same cover, you'll get a very even diffusion of light. The white material transmits light very well. That's helped by the fact that this is built with a thin wall, strong enough to support it and make it rigid, but it is actually thin enough not to actually inhibit the light, and it produces very good diffusion. You can use the colours, try to use lighter colours and match them to colour of the LED inside, because otherwise if you were to say put them over a white LED, it would basically just filter out the it uses colour subtraction. It would filter out only the blue and it could look quite dull. But having said that, that could be a nice look in its own right with pastel colours. The size of the sphere at the top and the bottom, if you make them both the same, you'll end up with this traditional tubular lamp. If you make the sphere at the top bigger, you'll end up with a pygmy type lamp. You can make this any length. If you make it too long though, you could make a stylish lamp that is maybe 20 millimeters. This thing tends to work in metric, or certainly I work in metric in this. If you say make it 20 millimeter at the base, 6 millimeter at the top, but then you make it 100 millimeter long, you'll end up with a really stylish, pointy, long lamp, but the light will graduate down to virtually nothing at the other end, because it varies with inverse square law. The most of the light will be concentrated around this area, so it's better to keep the lamp short. But having said that, don't let it stop you experimenting and using those lamps. You could also use a focused LED that fired the light up to the end, and it may actually spread the light up. There's lots of experimentation you can do. These caps, I think I already said, don't use tungsten lamps in these, because they will potentially get very hot. This is a set that I converted to LED. This is just a small string running on low voltage, but you can convert full strings with a suitable power supply. I've covered that in different videos. And then you can make super low power custom LED light sets that you can pop LEDs into as you please. And these caps work very well with that. But the caps also work extremely well with these little heat shrinked LED sets. And that's more or less it. It's all down to experimentation. So the script is down below. Dive in, play with it, have fun, and have a great Christmas.